We're going to begin our talk on right triangles. The first thing we're going to use is the Pythagorean Theorem. You use the Pythagorean Theorem to find a missing leg or hypotenuse. So if we have a right triangle, which we have down here at the bottom, right triangle ABC, right triangle is a triangle that has one right angle in it. The sides that make up your right angle are called your legs. So side AB is a leg, side BC is a leg. The side that is completely opposite of that is called your hypotenuse. So side AC is your hypotenuse. The hypotenuse is always your longest leg of the triangle. So it has to be bigger than the two legs. And to use the Pythagorean theorem, the formula for it is leg squared plus leg squared equals hypotenuse squared. So if I add the sum of the squares of the legs is equal to the square of the hypotenuse. Leg squared plus leg squared equals hypotenuse squared. So for our first example, let's first identify if we have a leg, what our legs and what our hypotenuses are first. To find the legs, you want to look for your right angle first, and look for the sides of the right angles. So the sides of the right angles would be AC, so this would be a leg, and side BC, so this would be a leg, and the side opposite of the right angle is your hypotenuse. The general formula for your Pythagorean theorem is leg squared plus leg squared is equal to hypotenuse squared. So let's take out the leg, and hypotenuse and put in the numbers that we know. We know that one of the legs is going to be 3, so I can take out the leg and put in a 3. We know that the other leg has a length of 4, so I can take out the leg and put in a 4. And we know the hypotenuse, we don't know the hypotenuse, is an x. So I can take out the hypotenuse, put in an x squared. Then we need to solve this kind of like we solve, similar to how we solve quadratics. We're going to solve by taking the square root. First thing you need to do is simplify your exponents. So I would do 3 squared first, which is 9, and then 4 squared, which is 16. You can add 9 and 16 together to give me 25. Right, we want to solve for x because we want to know what this x is. Right now we have x squared. To get rid of a square, you have to take the square root of both sides. So I want to take the square root of x squared and the square root of 25. Square root of x squared is just x. Right, remember how we break down radicals? I'm going to find do a factor tree and find the pairs. Numbers that go into 25 would be 5 and 5. Since we have nothing left over, our answer is just 5. So x is equal to 5. This is a special right triangle. Since all the sides come out to be whole numbers, so 3, 4, 5, because the hypotenuse would be 5. Since all the sides come out to be whole numbers, this is called a Pythagorean triple. There are several sets of Pythagorean triple. A lot of them come by just multiplying these numbers by the same thing. So if I multiplied all these by 2, you get 6, 8, 10. That would be another set of Pythagorean triples. For our second example here, let's go through and identify the parts of the triangle. So let's do the legs first. The legs make up the right angle. So therefore, this would be a leg. AC would be a leg, and BC would be a leg. The side opposite would be the hypotenuse. And our theorem is leg squared plus leg squared is equal to hypotenuse squared. Alright, so my first leg we had was x. We don't know what it is, so we put in x. Our second leg was equal to 12. And our third leg, or our hypotenuse actually, is 18. So I'm going to take out hypotenuse, put in 18. I need to simplify my exponents first. 12 squared is 144. 18 squared is 324. Alright, this one we need to solve for x. Alright, so if we look at our problem, like on the previous example, x was already by itself. This time it's not. It has this 144 on the same side. So we need to get rid of that 144 by subtracting 144 from both sides. That would give me 180. Alright, so next I need to take the square root of both sides. 180 is not a perfect square, but we can break it down. This is a nice little review of what we did at the beginning of the year. So factor tree would be 18 and 10. 18 would be 9 and 2. 10 would be 2 and 5. 9 would be 3 and 3. Bring down the 2. Bring down the 2. Bring down the 5. You want to circle your pairs. Everything you circle goes on the outside. So I would have a 3 and a 2 on the outside. Left over I have a 5. And then to clean that up I can do 3 times 2, which is 6, and leave the 5 underneath. So that leg AC would be 6 times the square root of 5. Go ahead and pause the video to do the first you try. Okay, so first let's identify AC is going to be a leg. CB is going to be a leg. Opposite of the right angle is your hypotenuse. So I would set up 5 squared plus 8 squared is equal to x squared. 5 squared is 25. 8 squared is 64. 25 plus 64 is going to give me 89. Square root of both sides. 89 doesn't break down at all, so therefore just leave it as the square root of 89. And then go ahead and pause the video to the second you try. So to identify, AC is a leg, BC is a leg, side opposite the right angle is your hypotenuse. So it'd be leg squared plus leg squared is equal to hypotenuse squared. Okay, 9 squared is 81. 21 times 21, or 21 squared, is 441. Right here I need to get x squared by itself, so I'll subtract the 81 both sides. So x squared is equal to 360. Square root both sides. I need to break down 360, which would be 36 and 10. 36 breaks down to 6 and 6. 10 breaks down to 2 and 5. And you can stop here. Since you have pairs and these to the 2 and the 5 don't break down anymore. So my pairs would be 6's. So on the outside I have a 6. On the inside I have 2 times 5, which is 10. So Pythagorean Theorem, make sure you identify your legs. Legs are the sides that make up the right angle. The hypotenuse is opposite of the right angle, it's your longest side. And then do leg squared plus leg squared equals hypotenuse squared.